we'll start with the reactions series. Now we'll do reactions for different types of organic compound, starting with alkanes. So the first reaction is called as combustion. Combustion can also be called as also means burning. Basically, an alkane reacts with oxygen in high temperature and produces carbon dioxide and water. So, a hydrocarbon, which is alkane or alkene, on complete combustion. Remember, the key word here is complete. Complete combustion gives carbon dioxide and water. If it was incomplete, we also get carbon monoxide. Give CO2 and water. So now let's do some equations. We'll do methane. Methane, which is CH4 plus oxygen. What we get carbon dioxide and water. If we try to balance it out, for hydrogen and for oxygen. This is complete combustion, so we get carbon dioxide and water. Moving on, I want you to practice these on your own, but I'll show you as well. Plus oxygen forms carbon dioxide and water. I'll write them and then you can take a screenshot and try to balance on your own. I will give you the answer as well. C3H8 plus oxygen, carbon dioxide and water, C4H10 plus oxygen. Alkenes also undergo this reaction, combustion, but we are considering alkane in this part. Now try to balance these. Okay, now I'll give you the answer. This is going to be 7, 5, and 3, 2 there, 2 there, 4, 3, 8, 6, 4, and 10. So this is the complete balanced equation. Now there's another type of reaction that alkanes undergo. This is called as substitution. Substitution. So in substitution reaction, one of the molecules is going to get, or one of the atoms is going to get substituted with another atom. So let's do an example with methane. Let's say we have methane plus chlorine gas in presence of sunlight. What is formed if it undergoes substitution reaction? Let's try to draw the structural formula here. CH4 plus Cl, Cl and Cl. So basically, one of this gets replaced and this chlorine goes there. So C and H, 3 CH3, and then the fourth one is with chlorine, and then HCl. So what we get, CH3Cl plus hydrogen chloride. Now this is not, remember, this is not hydrochloric acid because this is not aqueous, okay? This is hydrogen chloride. Now I'll write the equations again, and I want you to balance it and try to find the answer. I did the first one. CH4 plus Cl2 forms CH3Cl plus hydrogen chloride. This is known as chloromethane. So I'll write this, and I'll give you some time to solve them. Plus Cl2. What do we get? CH2 Cl2 Cl2, and then CHCl3. It's very easy. You just have to draw the structural formula and replace one chlorine with the dichlorine, with the one chlorine atom with Cl2. Okay, now you can solve it. Alright, so first we get CH2Cl2 plus HCl, CHCl3 plus HCl again, and then finally HCl and CCl4. Let's try to name them. Are you able to name them? Okay, now I'll name them dichloromethane. Why? Because we have one carbon, two hydrogen, and two chlorine. So this is known as dichloromethane. Then we have trichloromethane, because another hydrogen is going to get replaced with chlorine, so this is trichloromethane. And finally we have tetrachloromethane, because all of them are replaced with Cl. Now if you notice, the products of substitution reaction are not always pure. Why do you think that is? This is because when a substitution reaction occurs with methane, for example, it forms a range of different products. Sometimes one hydrogen is replaced with chlorine. Sometimes a hydrogen is replaced with chlorine. So we get a range of different products. That's why it's not considered very pure, and we get different kinds of products. Products of substitution reaction isn't always pure, because many chlorine deuterated products are formed. And HCl hydrogen chloride is also produced. So it's not like you get one chloromethane only. Now, so if you notice, sunlight, as mentioned here, sunlight is very important. So all of them undergo sunlight. Sunlight is the important condition for this reaction to occur. Must for substitution reaction. This is must. Let me give you one more example. C2H6 plus Cl2. What do we get here? Very easy way, just draw the structural formula. I'll draw it here. C2 plus Cl. What happens? So we'll just replace 1 plus Cl2. We'll replace one chlorine, and this chlorine goes there. So we'll call this C2H5 Cl, and then obviously we get hydrogen chloride. This is substitution reaction, and of course it occurs in the presence of sunlight. Now, so we just did reactions of alkanes. Now we'll do reactions of alkenes. And as I mentioned before, one reaction is, as you can guess, combustion. Alkenes. Reaction number one is combustion, where you just get carbon dioxide and oxygen and water. Carbon dioxide and water. I will give you some time to solve these as well. First, we have ethene, C2H4 plus oxygen. What do we get? And another example is C3H6 plus oxygen. What do we get? Of course, carbon dioxide and water. Carbon dioxide and water. Now try to balance them. All right, so we have to, now I'll balance them. So we have two carbon. That means we need to have two carbon on the right side as well. Then we have 4 hydrogen, so 4 hydrogen as well. And then we have 1 2 3 4 and 5 6 carbon oxygen on the right hand side, so we need 6 on the other side as well. And then with propene, let's try to do this. 3 carbon here, so 3 carbon over there, and then let's hydrogen 6, so 3 into 2 is 6 here. How many oxygen are there? 3 plus 3 into 2 is 6, 7, 8, 9. This is going to be 9 by 2. If you want to write it in whole form, we just multiply all of them by 2. We get 9 oxygen, 2 C3H6, 6 carbon dioxide, and 6 water molecules. So both of them are correct. Now, another reaction that alkenes undergo through is known as addition reaction. Addition reaction. Now, I will draw ethene first. So C double bond C, and then this is bonded to 4 hydrogen atoms plus Br2. Let's try to do addition reaction. So in addition reaction, what happens is that double bond is broken down, and both of bromine go and attach to this carbon. Let's try to draw this. So C, single bond C, and then we only have, and the bromine we go and react with carbon dioxide, with our carbon. As simple as that. Let's try to name them. This is ethene. This is bromine. It's a brown color. It's a brown gas. And then what we get? So first of all, of course, you can call this ethane because you have the main chain, which has 2 carbon, and then it has 2 bromo. It has 2 bromo, so we call this dibromine or dibromoethane, and then they are attached to 2 different carbons, carbon 1 and carbon 2, so we call this 1, 2 dibromoethane. If it was if both of the bromine were attached to 1 carbon, for example such as this is going to have a different name. Can you guess what that would be? To dibromoethane. This is going to be again ethane. This will be ethane because there's 2 carbon. Again, dibromo, but it would be 1,1 dibromoethane. Both of them are attached on 1 carbon. Okay, now if they ask us to write some observation of this reaction, what do you think the observation would be? So first would be, we can say that color changes brown to colorless, because bromine gas is brown in color. As it gets used up, the reaction mixture changes from brown to colorless. And this is on a visual level. On a chemical level, what happens is that it's not a physical observation. This is on a chemical level. What happens is, in addition reaction, only one product is formed. Unlike substitution, in substitution we had, as you can see here, we had multiple products: chloromethane, dichloro, hydrogen chloride. But in addition, only one product is formed. Product is formed, and unsaturated alkane turns into a saturated product, because we're getting rid of the double bond. Saturated product. So these are 3 points that you can say. Alright, so I'll give you one more example. Let's see if you can do it. So we have CH3, CH2, CH, double bond, CH2 plus hydrogen chloride. Okay, try to solve this. In 3, 2, 1. Alright, now I'll solve it. So very easy way, we will just write CH3, CH2, because this hydrogen and chloride will come here and this bond will go. So CH3, CH2, CH, and then CH2, and then CH2Cl. If you want to name it, what will you say? So this is butene, or butanene, or butene and hydrogen chloride. It forms chloromethane. Now one more important way to identify this this reaction, which is called the addition reaction, has another name, and that is called test of unsaturation. Why? Unsaturation. Why? Because if we add hydrogen chloride gas in presence of sunlight, if we add it to alkanes, we don't observe anything. No observation. But if we perform this addition reaction on an alkene, we see the color change from brown to colorless. Hence this reaction, which is addition reaction, is also called test of unsaturation. What is a fuel? Fuel is basically, if you're asked to define fuel is basically a substance that releases energy upon burning. Basically, when you are performing combustion on a compound and energy is released, this is a fuel. Releases energy on burning. You might be asked to give examples for solid, liquid, and gas fuels. These fuels are used, they're taken from underground or from natural resources, and they are burnt to produce energy. they're used in cars and all that, but they're also very bad. They're not that good for environment. So solid fossil fuel would be coal. Liquid fossil fuel is going to be petrol that we add in our cars. Petroleum. And then a gaseous fossil fuel is going to be natural gas. Now, if you may know that natural gas is another name for methane, which is methane, but if when you're identifying it as a fuel, you should say natural gas. So, moving on to another topic, which is called as cracking. When you think of the word cracking like cracking an egg. What happens? You have an egg, you crack it, and you get two products, right? One big egg breaks down into two products. Same happens when you're cracking your fuels, when you're cracking your large hydrocarbons. So cracking is just a process where complex hydrocarbon molecules are broken down into simpler hydrocarbon molecules. Complex hydrocarbon, for example, alkane or alkene, that have a lot of carbons, maybe C20, C30, like that. Complex hydrocarbons are broken into smaller, for example, methane or ethane, broken down, and so on, into simpler hydrocarbons. What is their conditions? I'll give you one example and the conditions of cracking. So condition is going to be 500 degrees Celsius. This is going to be the temperature. And we also need a catalyst, because just heating is not enough. We need a catalyst, which would be aluminum oxide, Al2O3, or chromium, Cr2O3. This is used as a catalyst. These conditions are for all cracking situations, for all cracking reactions. Let's say we have C15 and H32. That's it. This undergoes cracking. That means the right conditions are met. The temperature is 500 and one of the above catalysts is present. What do we get? We just get two carbon molecules, for example, that have a less number of carbons. We can say C6, H14, and how many carbons are left? 9 are left to complete 15. C9, H18. Actually, you can give any number of carbons. Now, we can also have C8, H18. This is an alkane, so you have to apply general formula of alkane, which is CnH2n plus 2 to find out how many hydrogen atoms should be present. And then what about this one? This is going to be C7, H14. You can have more as well. You can have C5, you can have C10, and so on. Now I want to give you another example. C4. Not C4 is already simple. Maybe C20, H42. Try to identify 3 equations for this. You can do this on your own. It's really easy. You just have to make sure that on the right hand in your product side you have the number of carbon and hydrogen balance out. Like carbon should add up to 20 and hydrogen should add up to 42. What are the advantages of cracking? That is, it conserves natural resources. Conservation. For example, if you obtain maybe from nature or by a chemical reaction or something like that, you obtain, for example, C15H32, and you don't really need it. You can break it down and you can get a lot of methanes. You can get a lot of gaseous fossil fuels, and this can be used as as a fuel. So you can use this. You can break down your complex hydrocarbon into a simple hydrocarbon that suits your needs. Suits your need, right? So you're conserving natural resources. Now, sometimes hydrogen is also formed. It is also formed. Let me give you the example for that. C15H32. You can see this is an alkane. What happens is we get hydrogen as a byproduct. Now let's let's write down the other simple hydrocarbons. We can say we get C6H12. Now this is not an alkane, this is an alkene. To get hydrogen, we need to have an unsaturated hydrocarbon, because there if it was alkane, this hydrogen would be part of it. But this is alkene, this is double bond, so this hydrogen can be formed separately. And then we can add our remaining carbon, which would be C9H18. We can count 12 plus 18 plus 2. This is 32. So it's balanced. Another advantage would be you get a mixture of alkanes and alkenes. Now we'll go for reactions of alcohols. So first we'll specifically focus on ethanol. And in ethanol we will say ethanol or manufacture of ethanol. How can ethanol be produced from nature, from another hydrocarbon, to be specific? Manufacture of ethanol. Basically, there first is we can have different ways. First is very common. This is called as fermentation. Fermentation occurs in it occurs in bread. It occurs in presence of yeast. Basically, what happens is when you have a glucose solution on fermentation gives ethanol and carbon dioxide. On fermentation, not on fermentation. Produces ethanol and carbon dioxide gas. Okay, another way in which ethanol can be manufactured is by hydration. By hydration of ethene. Ethene, because it has 2 carbon, and ethanol also has 2 carbon. Hydration of ethene. So what happens is we have ethene, C double bond C, H, for hydrogen, plus HOH, which is in its gaseous form. This produces ethanol, because both of this hydrogen and this OH bonds with the carbon atoms as the double bond breaks. And what's formed? This is ethanol. But it has some conditions. Hydration of ethene occurs under certain conditions. DITIONS. So the conditions are, you need to learn them, which is it occurs at 300 degrees Celsius at 60 atmospheric pressure, and phosphoric acid H3PO4, which is phosphoric acid, that is our catalyst. When all of these conditions are met, ethene can be hydrated into ethanol, phosphoric acid. Before we move on, I want to talk about conditions of fermentation. To do that, of course, yeast is necessary. Yeast must be present. Conditions are yeast, and then an optimum temperature of 37 degrees Celsius. That means it can occur at other temperature as well, but it's going to be really slow. At 37 degrees Celsius, the rate of reaction is going to be the highest. Basically, there's this enzyme which is known as zymase. This zymase is responsible for converting glucose into ethanol. Converts glucose to ethanol. And yeast respires anaerobically. That means in the absence of oxygen, respires anaerobically, and that helps in producing ethanol. Anaerobically, helping in fermenting ethanol. The equation for fermentation. So glucose is going to be C6H12O6. This is aqueous. So in presence of yeast and 37 degrees Celsius. So basically the conditions are yeast at 37 degrees Celsius. Now enzymes is present in it, right? That is responsible for converting glucose to ethanol, but the conditions are yeast, and at 37 degrees Celsius we get C2H5OH plus carbon dioxide. To balance them, we need to add 2. So 2 ethanol molecules are formed per molecule of glucose. This is glucose, and this is ethanol. Ethanol and glucose. So to sum up, if you want to produce ethanol, there are 2 ways, which is fermentation and hydration of ethene. In fermentation, basically, glucose is fermented into ethanol and carbon dioxide in presence of yeast at the optimum temperature of 37 degrees Celsius. The equation is this: C6H12O6 in presence of yeast and 37 degrees Celsius, you get 2 molecules of ethanol and 2 molecules of carbon dioxide. The other equation is that ethene is hydrated into ethanol. So the double bond of ethene is broken down. H and OH react with ethene, and you get ethanol. The conditions are 300 degrees Celsius, 60 atm, and phosphoric acid. And then you get a molecule of ethanol. What are the observations when fermentation is occurring, for example? Basically, carbon dioxide is formed, right? So first we can say, easy one, bubbles of colorless, odorless gas is observed. Colorless because it has carbon dioxide, has no color, it's present all around us, and thankfully it is also odorless. Imagine if carbon dioxide had some odor, we had to bear with it every second of our life. So bubbles of colorless, odorless gas. And secondly, carbon dioxide. This is also known as the test for carbon dioxide. Carbon dioxide turns clear lime water milky. Turns clear lime water milky. This is also known as the test for CO2. Now, in this, when we're trying to produce ethanol using yeast, what we do is that after we get ethanol, yeast is separated by filtration to get so we can, because we don't want yeast in our final product, right? So yeast is separated by filtration. So if you get a question, How can yeast be removed? Yeast is removed by filtration. You might have seen yeast when you are making pizzas. Yeast are, they're small particles. They're small, like balls, maybe small particles, which can be easily separated by filtration. Now, this glucose in presence of yeast form ethanol, but when ethanol is specifically produced by fermentation, this is known as fermented liquid. This is called as fermented liquid. So what is fermented liquid? These are some extra notes basically regarding fermentation. So fermented liquid when ethanol is obtained by fermentation. I'm actually giving you some points or some important questions that you may face while solving past papers regarding fermentation. Now, let's say you have your fermented liquid. Now glucose is there too, right? What will you do if you want to concentrate your fermented liquid? Which technique you're going to use? So that technique is going to be fractional distillation. To concentrate the fermented liquid, we do fractional distillation. I can underline it. So three important points are that yeast can be separated by filtration. Fermented liquid, this alcohol is known as fermented liquid, and if you want to concentrate the fermented liquid, you have to perform fractional distillation. Now, I will draw an example. Let's say we have a container. This is again, we're just talking about fermentation to produce ethanol. All right. So we have an aqueous solution of glucose and yeast. Aqueous glucose plus yeast. Now, what they did here is that they also made an airlock. Here, excuse my drawing, please. This is an airlock, and this is the airlock. There is some water present which acts as an airlock. So the question here is, what is the purpose of the airlock? Why is airlock present? Why airlock? So basically what happens is in this in presence of aqueous glucose and yeast, ethanol is formed, right? But ethanol in presence of oxygen can be oxidized into ethanoic acid. To prevent oxidation of ethanol into ethanoic acid, we provide the airlock. To prevent oxidation of ethanol into ethanoic acid. So that's the first point. Now, second question is, after some days fermentation reaction stops. Why do you think fermentation reaction stops? Because of ethanol. What happens is the ethanol that is produced, it kills the yeast. Glucose got used up. Alright, so now we can discuss some advantages and disadvantages of hydration and fermentation. Just as a quick reminder, hydration is when you have ethene plus HOH, you get ethanol, which is C11C, hydrogen hydrogen, hydrogen, and then OH. This is ethanol and H. So what are some advantages? First of all, pure ethanol is formed. As you can see in this reaction, there is no side product. There's no byproduct. Only pure ethanol is formed. So pure ethanol is formed. Another advantage is that it's a continuous process. As we saw earlier, in fermentation, the ethanol that is producing is going to kill the yeast. So the process stops. You have to intervene, or you have to quickly remove the ethanol or the yeast. If you remove the yeast, it can be used in another reaction, and if you remove the ethanol, it can help the reaction to continue. Now, another advantage is no greenhouse gas is produced. Greenhouse gas is usually for organic compounds is, of course, carbon dioxide. Could also be methane. No greenhouse gas formed, so that means it's very environmentally friendly. But it can be it has some disadvantages. First disadvantage is that raw material, which is our ethene, raw material is obtained from non-renewable source. Raw material, because it's a natural compound, is ethene. Maybe it's taken from I'm not really sure, but it's taken from a non-renewable source. So once it finishes, you won't have more in nature. You can artificially create it in labs, but that is going to be very expensive as well. The process is expensive because it requires a very high temperature, right? It needs to be 300 degrees Celsius, whereas fermentation occurs at 37 degrees Celsius, which is really, the temperature is very low comparatively for fermentation. It's expensive, more energy required. And we can discuss one more, that it needs strong vessels. So again, if you're heating at your ethene to as much as 300 degrees Celsius, that means you cannot perform this in a regular beaker, right? It has to be some very temperature resistant, some strong vessels are required. Now we can discuss some advantages and disadvantages of fermentation. The first advantage is that it's a very cheap process. It's happening every day. We perform it every day in our everyday lives, when making breads, when making pizzas. We are producing that. Raw material is obtained from a renewable source because it's glucose. Glucose is present in such huge quantities all around us. So is obtained from a renewable source. And another advantage is that conditions are easily maintained. Conditions are only yeast and 37 degrees Celsius. Yeast and 37 degrees Celsius temperature are easy to meet. Easy and cheap. Easy to meet, right? But just like every other point, it has some disadvantages as well. First is that it's a slow reaction rate. I don't know, I'm going to talk about pizzas again. When you make pizzas, you need to leave your dough for 2 hours, right? So it takes a long time to produce ethanol. And one more thing, impure ethanol is produced. Impure ethanol is produced because because of this. Where is our fermentation? There. Some carbon dioxide gas is produced, and also yeast is going to be there. So you will need to filter out the yeast, and you will need to concentrate here, as mentioned here. You will have to concentrate that and perform fractional distillation. So you will need to do both. If the yeast is extra, you need to filter out the yeast, and you have to perform fractional distillation if you want to concentrate your ethanol. Now, greenhouse gas is produced, so it's not very eco-friendly if you're doing it in a huge amount. Greenhouse gas formed. Greenhouse gas here is carbon dioxide formed, and it needs a relatively large vessel is required. So here is the overview of the advantages and disadvantages of hydration and fermentation.